Hello there and welcome to a brand new lesson. This is Have Your Numbers, where we learn maths the easy way. In this lesson, we are looking at some applications of sequence. By the end of this lesson, you should be able to identify whether a real-life problem requires an arithmetic or geometric sequence model. You should be able to translate word problems into correct sequence notations and formula. You should be able to solve problems involving salary increments, simple savings, and linear growth. You should also be able to solve problems involving compound interest, population growth, and depreciation. And finally, you should be able to interpret sequence answers in the context of the original real-life situation. Without much ado, let's quickly look into it. Sequence, geometric sequence, exponential, that is exponential sequence, arithmetic or linear sequence, appear everywhere in finance, in science, in our daily lives. The key skill is what? Recognizing which type to use. For instance, in savings or in salary, we have arithmetic sequence in some circumstances. Even in savings as well, when it comes to compound interest, it is a form of geometric sequence. Now, in population growth, that of bacteria and what have you, since the bacteria grow at a faster rate or by a factor, we say it's a geometric sequence. When it comes to business, when you are depreciating or appreciating, it does so geometrically and not linearly. Construction also has its share in what? Series, that is arithmetic sequences or geometric sequence. And then finally, even nuclear physicists use sequences as well. That is for decay of radioactive elements. The most important thing is you looking at how to actually model out from the stories you have to get your equation. So to be able to model these sequences from our real world problems, there are 5-step modeling approach, and they are very simple. First one is for you to read carefully. So if you have any word problems at all, any word problem at all, you need to model out your sequence from it. You have to read carefully to be able to identify what is a constant, what is the fixed amount that is being added, or what is the fixed amount that is being multiplied. This then gives you an idea as to whether it is arithmetic or what? Geometric. Now, after identifying your constants, you then define your variables. So you state what is A and then D. That is if it is what? Arithmetic. You state what is A and then R. That is your geometric. And then you represent your N. That is your N term. With all these parameters, you then go straight forward toward writing out your formula. So UN equals A plus N minus 1 times D. That is for a linear arithmetic sequence, or you use that of the exponential. Then you now solve for what is asked of. That is your required solution. Then finally, you interpret your answer in the context of the question you are solving. With this, there is no word problem. You can't actually work. Now, in as much as there are so many applications of these sequences, we'll just look at one for now. Then in our questions, we'll look at more. So one we call the compound interest. Unlike in elementary school where we consider the simple interest, and we say the simple interest is equal to what? The principal times the time, then times the rate, all over 100. That is if you don't have this as a percentage. Compound interest is a different story altogether. Because for compound interest, whatever you earn at the end of a period is invested again and it compounds. So if you invest a principal P and you are given a rate of R%, after a period of n years, then the amount that you accumulate is what? Your principal, then times into bracket 1 plus the rate over 100 all to the power n. That is your formula for what? Compound interest. And this is a geometric sequence. You know why it's a geometric sequence? Let's look at this. So we know for geometric sequence, we have our un being equal to what? The a times r to the power n minus what? 1. If you are to compare it to what we have here, amount equals p times 1, then plus your r over 100 all to the power n. Then our a becomes the what? P. You see that? And our r becomes all of this we have over here. You see, so there's the key connection between the compound interest and the what? Geometric sequence formula. With this said, let's not dwell on it. Let's move to some questions that will require us to apply all that we have learned. So for our first question we have here, it says Kofi starts a job with a monthly salary of 1,800 cedis and receives 150 increments every month. What will his salary be in 12 months or in the month 12? Then when will his salary first reach 3,000? What type of sequence is this? So you'd pay attention and then get the clues from it. He says there is a monthly increment. So every month there is a plus of 150. And looking at the two types of sequence we have, arithmetic has to do with what? Addition, constant addition. But geometric has to do with what? Multiplication. Hence, this is actually an arithmetic sequence. So we want to model what? An arithmetic sequence. So with that, he says he starts a job with a monthly salary. This is what is going to be paid. That is the first payment. So A, which is the first, is what? 1,800. Then for every month, an additional 150 is going to be added to it. That becomes our common difference. The 150 cedis added each month. Hence, our model becomes, the general theme is what? Using A plus, then you have n minus 1 d, substituting we have what? 1,800 plus n. So n minus 1, then times our common difference, which is 150. We would want to simplify this further. So upon simplification, we have 1,800 plus 150 times n. That gives us 150, and then minus 150. Grouping like terms and simplifying, we have 1,800 minus 150, which would then give us what? 150 n. So we are choosing to write this first. Then 1,800 minus 150, which gives us a positive 1,650. So this now becomes the general nth term formula. And for that matter, if you want the first term, we are just going to substitute n to be 1. For second, n is going to be what? 2, in that order. So we just keep changing just our n. In that case, for the first part of the question, it says, what will his salary be in month 12? So in month 12, so we say in month 12, it simply means that our n is equal to what? 12. Hence, for the 12th term, we have, substituting into our formula, 150 times n, where n is 12, then plus your 1,650. So evaluating that, we have 150 times 12, which then gives us a 1,800. So you have 1,800 plus a 1,650. Adding that together gives us a 3,450. So this is to say that at the 12th month, this is the salary he is going to receive. That is Kofi's salary. The second part of the question says, when will his salary first reach 3,000? So if you want when the salary is first going to reach 3,000, then it simply means for UN, when is 150N plus 1,650? When is this ever going to be equal to what? 3,000. So it's all about solving for your N. You see, so solving for our N, we then focus only on this side. So that we have 150 N plus 1,650, which is equal to a 3,000. Trying to make our N the subject, we have 150 N, which is equal to a 3,000 and minus 1,650. So 150 N is now equal to 3,000 minus 1,650, then gives us a 1,350. Then all we need to do is to divide both sides by 150. So we have our N being equal to what? 9. So we form our conclusion. This is then to say that, therefore, the month 12 salary is what? 3,450. And the salary will first reach 3,000 in the 9th month. As simple as that. So let's look at our second question. Our second question says, a town has a population of 20,000 and grows at 4% per year. What would the population be after 6 good years? After 6 years. So what model is this? The population is growing at 40% each and every year. 40%. That is 4 over 100. It is a fraction. You see? So with that, the fraction is multiplying the population. And we know the type of sequence that has to do with multiplication. That is a geometric sequence. And for our parameters, or first of all, for the model we want to work on, it is what? A geometric one. If it is a geometric sequence, then let's write out our parameters. So our A, which is the first term, it says a town has a population of this. So 20,000 is the initial population of the town. And it is growing at a rate of 4%. It is growing at a rate of 4% growth. Now this 4% here, we would need to actually change it into our R. Now for this R over here, it is also another term that we'll need to discuss. So you might be confused and then actually write your R as just 4%. But if you use this 4% to work, it is going to be wrong. The reason being that this 4% is actually the growth rate. You see, the growth rate, that is the rate at which the population is growing. But if you want the growth factor, then you would have to add 1 to it. So if I say we have a population of, let's say, 100, and the population is actually growing at 4%, then 4% of this one is actually 4. But if we now want the total population after the growth, then we would have to add the 100 again to the 4 to tell us that it is what? 104. That is after the growth. You see? So in terms of percentage, we have 4% here. If you have to change this into decimal, it is actually a 0.04. But we want to add the initial population, so that with that we'll get the initial population plus the growth that is actually taking place. So we don't settle with what? The 0.04. Remember, we said when the rate r, that is in our lesson on geometric sequence, if r is a decimal, then it simply means the population is shrinking, it is becoming smaller. But this is not the case, it is rather a growth. So it is supposed to be what? Plus 1. So that r then becomes a 1.04. You see, so the r we'll be using here is 1.04. I do hope you've taken note of the difference. If you only use the 0.04, the population will gradually die off. But this we want is a growth. So we always add the original population to it. So with these parameters, we have our a, we have our r. Hence, we can then say our un is actually equal to a, which is a times r raised to the power n minus 1. Substituting our values, we have 20,000 then times our r, which is a 1.04 all to the power 6, all to the power n minus 1. But it says what would be the population after 6 years? We want the population after 6 years. So for 6 years, it simply means that what? Our n is what? A 6. So with n being a 6, u6, that is the set term, will be 20,000 times into bracket 1.04 raised to the power 6 minus 1, which is a 5. Evaluating this whole thing, we are going to get a 20,000, and if you punch this on your calculator, you are going to get a 1.2653. If you multiply these together, you'd have a 25,306. That is rounding it to the nearest whole person, because humans are not measured in decimals. So we are rounding this. So that you have a 25,306. So this is to say that the population after 6 years with this growth, 4% per year, is going to be a 25,306. So we conclude by saying, therefore, the population after 6 years is approximately 25,306. This is the most important place I would want you to understand. If you're able to understand why we don't keep r to be 4%, you'd be good to go. The reason being that if you keep it as 4%, the population will shrink. So we always add the initial population, which in terms of decimal, it is 1. In terms of percentage, it is 100. Let's look at our third question. Our next question here says, Amma invests 5,000 in an account that pays 8% compound interest per annum. How much will she have after 4 years? And how many full years until her investment exceeds an 8,000? This is clearly a compound interest. So her initial investment, A, her initial investment, which was A, also called the principal, is what? 5,000. Now, in an account that pays 8%, so I've told you that if you have the percentage, always add a 1 to it. So we know 8% is actually a 0.08. So our R, which is the common ratio, is then going to be what? A 1.08. If you are to use only this 8%, it simply means her money is in the bank even though she has invested it, it will wear out. She would end up getting what? 0 in her account. Hence, we need to what? Add this 1 to show the growth factor and not just what? The growth. So we have our A and we have our R. Hence, with that, we can write something out. So our UN, in this case, since it is geometric, becomes our A times the R to the power N. Substituting, we have our 5,000 then times our R, which is 1.08 all to the power N minus 1, not just N, so N minus 1. This is the formula we are going to use. Now, how much will she have after 4 years? After 4 years, it simply implies our N is what? 4. So if N is equal to 4, then our U 4, that is the fourth term, is going to give us a 5,000 times a 1.08 all to the power 4 minus 1, which gives us a 3. This, when punched on the calculator, will then give us a 6,802.44. So this is the amount she's going to get after the 4 years. 6,802.44 cedis. Take note of that. And it goes on to say how many full years until her investment exceeds this. If you want the investment to exceed this, it's simply an equation you want to write to find your N. So that is to say, a certain UN gives us what? 8,000 cedis. And we know the UN is actually equal to what? The general formula, which is what? The 5,000 times 1.08 all to the power what? N minus 1. We'll be doing a little bit of calculation here. We can first of all choose to divide both sides by 500. By dividing both sides by 500, we have 8,000 divided by the 5,000, which is then equal to 1.08 all to the power N minus 1. Solving further, we know all these zeros are going to cancel out. If you have a calculator, you can just punch all this to give you your answer. So 8 over 5 will then give us a 1.6, and you say 1.6 equals 1.08 all to the power N minus 1. Now let's take logarithm of both sides to what? To the base 1.08. And with that, we are going to get a log 1.08, 1.6 equals log 1.08, 1.08 all to the power N minus 1. So with that, if you have to evaluate all we have here, then we are going to get a 6.107, which is then equal to, so let me just leave it as 4 decimal place, which is equal to N minus 1. You know, the log of a number to the same base gives us 1. Making N the subject, we have our N, which is equal to 6.1070 plus 1. And this would give us what? A 7.1070. Since we are talking of years, then we are just going to approximate that to what? 7. And that is all. So our conclusion will be that after 4 years, he's actually making 6,802.44. And the investment exceeds 8,000 only after what? 7 years. Only after 7 years. Our question number 4. Question number 4 says a motorbike costs 12,000 new and depreciates by 15% each year. Find its value after 3 years and after 5 years. In which year does its value first fall below 5,000? So how do we go about this? This is obviously a what? A geometric progression. Now, since there's a depreciation, take note of what is going to happen. So our A is simply a 12,000. Now R, remember when we're talking of population, population is a growth. So we needed to add 1 to it. Investment is a growth. So we needed to add 1 to it. For this case, for the 15%, we are talking of depreciation. So we are rather going to subtract the 15% from the 1. You see, so it's going to be a 1 minus 15% is simply a 0.15. So our R is simply a 0.85. And this here is a decimal. If the ratio is a decimal, it drastically falls towards 0. And that is what depreciation does. It is a loss in initial value. So we have our A and then our R, hence we can write our general formula, which says UN is what? The 12,000 times your R, which is a 0.85 all to the power n minus 1. So with that, it says we have to find the value after 3 years. That is U3. U3 is just going to be a 12,000 times 0.85 to the power, since it is 3, is going to be 3 minus 1, which is a 2. Evaluating this gives us a 7,000. That is 7,369.35. So you just punch this on your calculator, you are good to go. Then for the U5, it is also going to be at 12,000 times 0.85 all to the power n, which in this case is 5. So 5 minus 1, giving us a 4. So with that we have what? 5,324,000.44. Kindly punch all these on the calculator, this and then this, to confirm the answers we have over here. So this is going to be the value after 3 years, and then this is the value after what? 5 years. Now the next question says, in which year does its value first fall below 5,000? So just as we did for the previous one, then we simply want what? Where 12,000, that is our UN, is going to be below. So for it to be below, we say UN should be less than what? The 5,000. And we know UN to be what we have here. So we want 12,000 times 0.85 all to the power n minus 1 to be below what? 5,000. So this is what we want to solve for, and then find n. So solving for our n, it is all about making our n the subject. So just as we did for the previous one, we are just going to divide. So dividing both sides by the 12,000, this takes out this, and then we'll be left with a 0.85 to the power n minus 1, which is less than, if we simplify this, we have a 5 over 12. Or instead of 5 over 12, you can just change it to decimal, so that it's going to be a 0.41 then 66. With this, we are going to take the logarithm of both sides to the base 0.85. So log to the base 0.85, then 0.85 to the power n minus 1 is going to be less than log of 0.4166 to the base 0.85. Log of a number to the same base gives us 1. Hence, we have our n minus 1, which is less than, evaluating this on our calculator, then we are going to get a 5.3. So 5.387. Making n the subject, we have n is less than 5.387, then plus a 1. So our n then is less than 6.3. Since we are talking of years over here, then it's 6. 6 is okay because this decider is even less than 5. Now, what does this mean? If you go back to the question, it actually says what? Find in what year does its value first fall below 5,000. You see, and we could even end here because n is less than 6.3. So if you want the year, the actual year that it will fall, then we just take this, which is the 6. So it means at year 6, its value or money is going to fall below what? 5,000, as we have solved over here. And we did that by just making n the subject. So we can then conclude by saying that, therefore, after 3 years, his amount he's getting is what? 7,369.35. After 5 years, it has also reduced. So now we have 5,324.44. Then it falls below 5,000 in the 7th year. Our final question for this session. Plan A offers a starting salary of what? 3,000 per month, with 200 added each month. Plan B offers 2,000 per month and a salary increase of 6% each month. Which plan pays more in month 15? Then after which month does plan B permanently overtake plan A? If you look at it carefully, for plan A, plan A is actually following a linear sequence. So we know a linear sequence is un is equal to what? A plus n minus 1 times the d. And in this case, A is going to be what? The 3,000. And then our D is also going to be the 200. So with that, we simply say our UN, the general term is what? 3,000 plus n minus 1 D, which is 200, which can be simplified as what? 3,000 plus 200 and minus 200. We have to simplify further. We are going to get what? Our UN being equal to a 200 and then plus a 2,800. This is what we have. Now this is the general formula for plan what? A. Let's quickly do everything we have to do for plan A, then we come to plan B. So in month 15, simply means our n is equal to what? 15. Then our UN, or the 15th term, that is month 15, is going to be what? 200 times 15, then plus 2,800. This, when evaluated, will then give us a 5,800. So on the 15th month, plan A is offering a 5,800 cedis. Let's then look at plan B. So for plan B, which is actually a geometric sequence. And we know for geometric sequence, we have our un being equal to a times r to the power n minus 1. So in this case, our a is it's offering what? 2,000. That is the initial payment and an increase of 6%. So based on all that we've done so far, if you are getting an increase of 6%, then it simply implies that R would be equal to 1.06. With that, if we have to substitute, we have our UN, which is equal to what? 2,000, then times our R, which is 1.06, all to the power n minus 1. This is the general term. Then for our 15th term, where n is equal to what? 15, we'll do a substitution and say U15, that is the 15th term, is going to give us a 2,000 times 1.06 to the power 15 minus 1, which is what? A 14. Evaluating this on your calculator, you are going to get a 4,521.84. If you are to compare the two, it simply means even on the 15th month, the linear sequence is paying more than what? The geometric sequence. Now we want to test when or in which month are we actually going to get more pay in plan B. So this is just to inform us of a decision, you see, so that right on that particular month we switch to the other one, then we'll still be enjoying a bigger pay. So what we actually want now is when plan B is going to be greater than plan A, you see. And we know the two equations. So these are the two equations. We want when this one here is plan A is going to be greater than this here, which is plan B. We can't directly make n the subject so that we actually solve for n. Hence, we can test. So in testing, we pick various values of n and then we settle at where our n actually gives us a value of plan B being greater than that of plan A. So for now, we have got up to 15. And as at 15, plan B is still less than, you see this plan B, it is still less than what? Plan A. So let's start at around 20 and see. So you take your calculator and you punch all of this on your calculator. Then press calculate where n is equal to what? So at n equals, let's start from 20. At n equals 20, we are going to get plan B giving us around, that is to say plan B is going to be equal to our 2,000 then times 1.06 to the power, so instead of 20 minus 1, we are going to just write a 19. Evaluating this gives us a 6,058. Now let's test what plan A also gives us when n equals 20. So at n equals 20, A is also going to give us a 200 into bracket 20, then plus a 2,800. And that, when solved, gives us a value of 6,800. So even at 20, A is still leading. So we are doing this till we get to where B leads. So you'd have to continue with this substitution until you get there. For n equals, let's take somewhere around 22. So for n equals 22, if you substitute properly, you are going to get your A being what? 7,000 6,200. And your B, on the other hand, being a 6,799. A is still leading. At N equals 23. We are going to get our A being equal to a 7,400. And then B is also going to be what? A 7,207. You see? Now let's skip 24, or you can do that yourself. And then let's go to what? 25. So at N equals 25, we are going to get our A, giving us a 7,800. And then our B is also going to give us an 8,035. And this is where B finally overtakes what? A. So it is on the 25th month that if someone was actually subscribed to Plan B, the person would gradually overtake someone who is subscribed to Plan A. So our conclusion. So you can say that therefore, it is in month 15 that Plan A has what? 5,800. For Plan B, it has what? 4,522. And Plan B permanently overtakes after 25 months. You see, that is it. I think this lesson has been very, very long, and then we would have to end here. But as usual, I'll leave an exercise for you so that you try in order to test your understanding. Just 5 questions, of course. So here are 5 questions you have to test your understanding on. They are just basics questions based on all that we have done so far. Just have beyond numbers so you learn maths the easy way. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know in the comment section. When notified, I'll address that for you. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.